A very good morning to everyone. It's me, Krishti Ranjan of class 9D. So today we are going to discuss about the topic gravitation. So in this chapter what we are going to learn about is gravitation force, universal gravitation constant, acceleration due to gravity, relation between capital G and small g, relation between SI and CGS unit of force. So let's begin with it. Our first topic is universal gravitational constant. So let's understand it. Consider that two bodies A and B are at a distance that is r apart from each other. The mass for A is m1 and the mass for B is m2. Now let's understand what is universal gravitational constant. It states that two bodies attract each other by a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let's understand it mathematically. The force that is directly proportional to the product of their masses of the two bodies. The bodies are A and B and the masses are m1 and m2. And the force that is inversely proportional to the square of the distance between them. The distance is r and what we are going to do is we are going to do square of it. Let's consider it our first equation and this our second. What will happen when we will combine these equations? Let's see. The result we are going to get is F is directly proportional to m1 into m2 upon r square. What we are going to do with this sign? When we replace this sign with equals to sign, we are going to add something to it. So let's add g. F is equals to g m1 into m. This is the formula for gravitational force. Let's talk about acceleration due to gravity. The acceleration produced in a body falling freely under the action of gravitational force of the earth. Acceleration due to gravity can be denoted as small g. Its SI unit is meter per second square or meter per second square. It can be written in both the ways. Now let's talk about the relation between the capital G and the small g. So there's a body A with a mass m and a body B with a mass small m. The distance between them is r. So according to universal law of gravitation, F is equals to g m small m by r square. Let's consider it our first equation, and according to Newton's second law of motion, F is also equals to m into A. Now let us replace this A by G. Then what we will get is F is equals to m into G. This is our second equation. Now we can see that F is equals to m into G and F is also equals to this. So now we can keep these both equations equal to each other. So now what we are going to do is mg is equals to capital G m by r square. So here we can see that this small n and this small n are cancelling each other. So let's cancel them. Then small g is equals to capital G capital M by r square. So here's the formula for acceleration due to gravity. So the last topic for today is equation of free fall. The first equation is V is equals to u plus gt. That is, final velocity is equals to initial velocity plus acceleration due to gravity into time. The second is h, that is height, is equals to ut plus half gt square. The third is v square is equals to u square plus 2gh. So that's all for today. Thank you and have a nice day.